Having first considered the physical state and the reactions of the occupants and how this can be related to building type, it's important to look at the process of escape and the maximum distances people can be expected to travel to escape from fire. And obviously, the distances people travel to get to safety has a direct bearing on the time taken to evacuate in the case of fire, and it's important to remember that travel distances will vary depending upon the type of building, the use of the building, and the occupancy of the building. And in most building designs, it's neither practical nor desirable to have final exit from all rooms where a fire may start. And for most situations, it's necessary to consider the process of escape in 4 stages. Stage 1. Escape from the room or area of fire origin. Stage 2. Escape from the compartment of origin via the circulation route to a final exit or entry to a protected stairway. Stage 3. Escape from the floor of origin to the ground level. Stage 4. The final escape at ground level. And in addition to the requirement to limit travel distances, it's also necessary to consider the flow of people through the exits from buildings. So a guidance on the number and width of exits that are required provided an adequate means of escape. Also in practice, this means that when planning or assessing the means of escape for a particular situation, there must be adequate numbers and widths of exits as well as adequate directions and distances of travel. And bear in mind that although it's important to consider the number and the travel distances, it's also important to consider the appropriate evacuation time and take into account those that may need to make use of wider exits, such as those using wheelchairs and walking aids. Here is the end of this lecture. Thanks for watching and see you later.